So our goal with this one is to look at two equations that are very similar. So for example, take a look at this. This is a sequence that is described as doing -3 times the sequence term plus 4. And then over here we have function notation. So a function f of x equals -3x plus 4. So let's first look at what they have in common, right? So they both have the -3 multiplier and then the plus 4 added on the end. Cool. How are they different? Well, this one is specifically a sequence, and this one isn't. This is a function like we worked with in the previous semester. It's just a general equation, relates an input to an output, not necessarily, though, a sequence. So they have sort of the same structure and pattern, but what we use them for may be a little bit different. Let's take a look at how this goes. So for our questions here, can the inputs be 4 in these? Here's what it means. In the first one, so in our sequence, for the input to be 4 means I'm putting a 4 in where the n is. So we can do that here. This is just going to be finding the fourth term of the sequence. So -3 times 4 plus 4, that's -12 plus 4. So the fourth term in this sequence is -8. So can I put a 4 into this sequence? Yes, I can. We just did. Let's now see if we can put that same 4 in over here for this function. Now on this side, having an input of 4 means the x would be 4. So a 4 in for this x, a 4 in for this x. And I hope at this point you're realizing, wait a minute, this is just the same calculation we did before. So on this one, when you input a 4, you get an output of -8, just like you did over here. The only difference is in how we interpret the result. Here, this -8 is the fourth number in the list. Here, there's not a list of numbers. We're just saying, hey, we have this relationship. When 4 goes in as the x, -8 comes out as the y. Okay, let's see what's under this next box. So can we put in a 4? Yes. Can we put in an 8? Let's see. If we put an 8 into here, I'd be saying find the 8th number in the list. So that's -3 times 8 plus 4. -24 plus 4 is -20. So yes, this works just fine. The 8th number in the list is -20. Over here then, if I put a 4, or rather an 8 in as the x, -3 times 8 plus 4. Now the calculation is going to be the same. A -20 comes out as the y. So this would be an ordered pair plotted on this graph. 8 for the x, -20 for the y. Okay, so far, even though they're structurally a little bit different and we interpret them a little bit differently, they're working pretty much the same. Let's continue on. Can the input be 5.5? 5.5. All right, well, let's see what that would mean here. A 5.5. So it wouldn't be the 5th number in the list, but it also isn't the 6th number in the list. I don't think we can use 5.5 here. If I'm counting terms in a list, I've got to be using positive whole numbers, my counting numbers, 1, 2, 3, 4, 5, 6. 5.5 doesn't fit that description. I actually can't use 5.5 in here. That's not going to work. Okay, so it doesn't work in this one. Can I do a 5.5 over here? Well, this is just saying put a 5.5 in where the x is. I'm going to pull up my calculator here. Do -3 times 5.5, which is -16.5. And then add 4 for -12.5. Yeah, over here, there's no problem. This gets to, I think, a big important distinction between a general function equation and specifically a sequence. When you're talking about a sequence, your inputs can only be these positive whole numbers. You can't use a decimal in a sequence. It doesn't mean anything. To talk about the 5.5th number in the list, What would that even mean? Whereas over here, we're simply saying, well, the relationship between in and out is this equation. You can put a decimal in, no problem. So it's all about interpretation. Let's take a look one more here. Can we put a -3 in as the input? Okay. Let's check over here on the sequence. A -3. We got to think if this makes any sense. The -3rd term in the list. So I don't even know what that would be like 3 or 4 numbers before the list started. What number are we looking for? That doesn't make a whole lot of sense. It's hard to interpret because in this context, in the sequence, it doesn't have any meaning. So in this sequence, can I use an n, an input of -3? It doesn't have any meaning. Over here, we have no such problem. I'm allowed to put a -3 into here. -3 times -3, that's just 9, and 9 plus 4 is 13. So in this equation over here, when a -3 goes in, a 13 comes out. So what are we seeing? I want to go to a graph here for a moment. Now I have set up this graph to show the terms of the sequence, the first 10 terms. And what I want you to notice is how it's not a continuous line. Now they kind of make a line, but it's our mind filling in those gaps. Really, these are just separate points that are plotted as you go along. They're not connected. I can see right there's big spaces between them. Look at the difference between this sequence and now if we plot this entire function equation. Notice that the blue function equation doesn't have any gaps. It actually is the entire line. So while they match up, like the line and the red dots, they're at the same places, the blue line is just allowed to exist at places where the input isn't a positive whole number, meaning there's more blue line showing up than there is red dots. That's generally how sequences are going to work when compared with a similar equation that doesn't have that sequence restriction. So here are some words. Let's give you a chance to read, and then we'll discuss. So pause as you need. So an important word here. I want you to know this word domain. It means the values you're allowed to input into an equation. So for a sequence, the domain is only positive whole numbers, meaning they're separate points. The word we use to describe something made of separate points is this word right here, discrete. Discrete means that your graph is made of separate points. For any other function, so for any other equation that's not specifically a sequence, the domain is determined by the properties of the equation. Very often, that just means you're allowed to use any number. There you go. Typically, that means the domain, the inputs you can use, is not restricted to positive whole numbers only. You can use decimals, you can use negatives pretty much all the time. And functions, a lot of the time, are continuous. So continuous just means unbroken. Now, it's important to note here, these are not really two separate things. Notice how well the sequence lined up with the blue graph. Technically speaking, a sequence is a function. It's just a special type of function. It's easiest to see here if we look at this Venn diagram. So functions, that includes a whole broad swath of types of equations and number relationships. Sequences are a special type of function, a special type of equation and number relationship. And that's why sequences have that extra restriction that the only inputs you're allowed to use are positive whole numbers.